Uh, Thank you all for joining. It's really nice to actually have this opportunity to share a little bit of knowledge on aviation, especially for pathfinders who want to get this honor. I know it's something that we all would love to have. So welcome, and I think we can just jump straight into the honor part of it and the theory of it. And please let's just make this interactive because one person talking is not fun. So you tell me what you know and I'll share with you what I know as well. So we can start, yeah. So I just wanted to ask the first question is what do you all think of when you think of aviation or when you think of aeroplanes? What do you think of? Just anyone if just feel free to talk. It's not a serious class. Okay, somebody said sky. Okay, that's interesting.
Fly.
Aviation with the sky, flying. Okay, aviation and flying. Okay,
Operating
aeroplanes.
an aircraft.
Okay, and aircrafts. All right. All of them are valid answers, and we'll start with what is an airplane? What is an airplane? Or we'll start with what is an aircraft? My apologies. We start with what is an aircraft. Yeah. An aircraft is literally anything or any machine that is capable of flying. Please don't confuse it with any flying machine. Any flying machine is not an airplane. Any machine capable of flying is a machine. So, like, just to give you a rough example, anything with wings, like if you have a paper aeroplane and you're flying with it, or you throw it in the air and it flies, that is not an aircraft because it's not a machine. That's just the simple, the most basic explanation of an aircraft. Any machine, that is the key word in the definition of an aircraft. Any machine that is capable of flying. So now once we go to now that we know that it's any machine that is capable of flying, we can go into the different categories of the aircraft, different types of aircrafts. You all already, I'm sure, 100% that you all know that. Oh, sorry. Roland, are you still moving the application? Right. The airplane, right? So the aircrafts have different categories. So when we talk about the categories of aircrafts, it's divided into airplanes now. Next is helicopters. You all must have seen helicopters as well. They are machines that can fly. We have gliders, we have power lift aircrafts, and lighter than air, which we will all go through individually later on in the lesson. But then the two main uh, aircrafts that are used today are aeroplanes and helicopters. These are the two that are mainly used for commercial purposes in today's aviation industry. We still have gliders, we still have lighter than air balloons and blips, but they are not used for commercial purposes. The two main categories of aircrafts that are being used are aeroplanes and helicopters, which helicopters fall under the rotary type of aircraft. It is the rotary type. Aeroplanes have propulsion type, which we will still get into, but the simplest understanding is aeroplane, the engines are in front and it moves through the air. Helicopters or rotary type, they have a vertical takeoff. You can go straight up or straight down to land. That's the main distinction between an aeroplane and a helicopter or a rotary type of aircraft. So looking further, oh, first let me ask, is that clear for everybody, the difference between uh, the aircraft, which is a rotary type, and which is an aeroplane? Okay, somebody said no. Okay, so I was trying to say, the aeroplane, the aeroplane is something that has wings and flies with the help of an engine or engines, multiple. It can either have one engine or two engines. That is an aeroplane. When you talk about a helicopter, it has a single engine on the top and it can take off vertically up or vertically down. That is a helicopter. An aeroplane, it needs a runway to get speed before it takes off. The two main differences in our category of aircraft that are used commercially. I hope that was clear. And if it's not clear, I promise you by the time we finish, you will have a clear understanding about the differences of a helicopter, which is a rotary type of aircraft, and an aeroplane, which is a fixed wing with landing gears type of aircraft. Okay, so aeroplanes, airplanes, they are a category. Under this category of aeroplanes, we have different classes. So they are different classes. The classes can also be known as different types of engines. So a class and an engine are the same thing. If you're looking at what type of engine an aircraft has, you will be talking about the class of that aircraft. I hope you get the relation. So under that class, you have, as listed here, we have a single engine piston aeroplane. So just by the name, you know that this class of aeroplane will have one engine, which is a piston engine at the front of the aircraft for flying. So the name basically says it's a single engine piston aeroplane. So the engine is a piston engine. It has one engine and it is capable of flying. So that is the first class. We have a single engine and an aircraft that is capable of flying. So the first class is single engine piston. Uh, I've written there in the PDF that is both land and sea because uh, the engine that is on the aircraft has nothing to do with where it can land. I just wanted to just put that out already, that just because the aircraft has a specific type of engine or if it's a specific class, it doesn't mean anything about where it can land. Where it can land completely depends on the landing gear that is fitted on the aircraft. So each class of aeroplane can either be on the land or on the sea, depending on the landing gear that is attached to that aircraft. So let's not get confused whether it's a land or a sea. Under a class, we only look at the engine or what type of engine the aircraft is going to use. So let's moving forward. We have a single engine piston aeroplane. We have touring gliders. We have single engine turboprop. That is another type of engine and another class of aeroplanes which use this specific type of engine, a turboprop engine. This is another class. So now this one will also have a landing gear to land on the land And if you want to land on the sea or on the water, you will put different landing gears. But the engine has nothing to do with where the aircraft can land. Okay. And then we have again multi-engine piston aeroplanes. So the only difference between a single engine and a multi-engine is already in the name. A single engine piston will have one piston engine at the front. The multi-engine, as the name says, it has two on either side of the wings. It has a left engine and a right engine, or engine one, engine two. Okay, I hope the classes and the types of engines won't confuse with what are the special aeroplanes that are coming down as well. But that is the main difference. Once you know that it is the category of aeroplane. So we start from from on top, the aircraft, any machine capable of flying. Under any machine capable of flying, you have airplanes, you have helicopters, you have power lift, you have lighter than air. Under these categories, the aeroplane is further divided into different types of engines that the aeroplane uses. So you will have a single engine piston aeroplane, you will have a multi-engine piston aeroplane, you will have touring gliders, and you will have a single engine turboprop engine, which we will also study the different types of engines, which is very, very similar to each other. And they more or less have the same basic working principle as the normal car engine, or the normal four-stroke bike engines that we use. Sorry, the two-stroke bike engines that we use back in India. They have a similar working, so we'll get into that a little bit later. Under the classes now, like we said that aircraft is any machine that can fly. They have different categories now: helicopter and aeroplane. Under aeroplanes, we have single engine, we have multi-engine, we have turboprop. Now these are further divided into categories or different types under the classes. Okay, under the classes, we have a single engine. Like I think most of you must have seen this as well, or if you're lucky enough, I should say, or if you all travel enough. There are different types of aircrafts that you see people flying. When you travel, even domestic flights, those domestic flights are not as big as the international flights sometimes, not always, but sometimes the domestic flights are not as big as the international flights. These come into types of ratings. So now once you know that the aircraft is above 5 tons or 5,700 kgs, you need to know that even if you can fly an aeroplane, even if you can fly a uh, multi-engine piston engine, or a multi-turboprop, or a single turboprop, or a single engine piston, you still need to go for special training if the aircraft is more than 5,700 kgs, according to the laws of the air. It doesn't matter if it is below 5,000 kgs, you can fly it, as long as you have one of the class ratings that are listed here. And then the special type is again a multi-engine turboprop, because a single engine turboprop are mainly used for, uh, let's say, short hauling of goods. If you, okay, I can give a good example for India. If you want to go from Calcutta to, let's say, Nepal. That is a very short flight. And the mountain areas that are around there, are not ideal for big aircrafts to come, which are above 5,700 kgs. So what they do is they take an aircraft that is below 5,000 kgs and they put fewer people inside and load it up lighter so that the journey or their trip is more successful. I hope I'm not losing you all, and I hope you all are understanding the difference in the aircrafts of how the commercial industry works. Of the big aircrafts go to better places, but the small aircrafts that are a little bit light, they go to the more dangerous places of mountains or where rivers are there or where landing strips cannot be made into tar or cement. Those are where the special ratings come into play. So the relation between all these different types of ratings or these different divisions in the aviation industry is just to make people understand that if you want to fly a single engine, which is a piston engine, you can fly any single engine, which is a piston engine, as an aircraft. The minute you want to change to a multi-engine, you have to go through again specialized training to start flying the multi-engine. Furthermore, if you want to learn how to fly aircrafts that are now heavier than 5,700 kgs, you will again go through more training to fly those aircrafts that are above 5,700 kgs. If you want to learn how to fly two turboprop, the difference being it's not a piston engine, it is a turbo engine now. Turbo, already we know turbo means anything that goes faster. So now when it's a turbo engine, you again need to go through specialized training. If you want to fly at night, you will have to go through specialized training. If you want to fly only instruments, which is not using your eyes to look outside, you look only inside the aeroplane and follow every instruction that your instrument gives you, you also need to have a special rating. If you want to become an instructor to teach other people, that is also under special ratings now. So all these different types of ratings, they come in just to differentiate or to tell the student that there is a level that you have to climb from one rating to another rating to another rating. So in aviation, more or less, your ratings can never finish. You can always get a new type of rating or you can learn how to do something new. Like I don't know if you all can see this under special ratings, there is an agriculture rating. That agriculture rating are for the farmers. They take your pesticides, they take your how to say, anything that you need to spray over your crops or your lands. These are the special ratings that mostly people in European countries or the US, instead of going manually or, to make things more or make life easier for them, they put the whole pesticide inside inside the aeroplane, and there's a specific timing that you have to open the door, and all the pesticide falls on the plants and on your crops. So that is again a special rating. So that is how the aviation industry works, and that is how it keeps dividing under under the different types and classes and special ratings that are there in aviation. But I will just wait for some time if anybody has any question about this part of differentiating between what type of aircraft, what class it is in, or whether it is a special rating. If anybody has any question, please don't hesitate to ask. It's open. Just yeah, just feel free. Yeah, please.
Well, I have a question.
Sure.
Okay. Uh, this is a question about, you said you need different trainings for different uh, uh, type of carrier which has different weight.
Yes, sir.
So now, what type of, I mean, how do you make a difference? Because when you drive a car which is of different CC, you know, the weight is different, but the way you drive is the same. And
Okay.
so what is it on the air?
Okay, so in the air, the difference is the manufacturer will give it to you because the bigger the aircraft, the heavier the parts.
I mean, you don't
That
carry, you're not carrying it, right? So
no,
what
no,
do you
no, we're not
carry?
carrying it. So the difference is once it becomes heavier, it has to become faster, it has to become stronger, and it has to be higher or bigger than normal aircrafts. So in a small aircraft, when you, okay, the easiest example I could give is if you're driving a car,
Mm,
which is a Maruti 800 or, uh, okay, let's say a Benz, it's fine, no problem. We're driving a Benz. The way you take a left turn to park your car will not be the same if you're parking a bus because
mm,
a bus is longer, a bus is
mm,
a little bit wider, and a
mm,
bus is a little bit slower in the initial torque to start moving. Your Benz
mm,
is immediate, as soon as you press the accelerator, your Benz is going to move.
mm,
But if it is a truck, when you press the accelerator, as much as power as that truck has, because of
mm,
the weight of the truck, the
mm,
initial movement of it will be a little bit slow.
mm,
And once it catches, it catches. And then
mm,
you, as the driver of the bus, need to know that this bus is this heavy. If I press the
mm,
brake now, it's not going to stop how my car stops immediately. It's going to stop
mm,
little bit in front of where I applied the brake.
mm. Okay,
So
okay.
that type of differentiation in the aircraft, if it is a small aircraft, you add the power, immediately you start moving. You know,
Mm,
your speed starts increasing, you can see things moving. But the bigger aircrafts, once they become heavy, you add the
mm,
power. I think even you all must have noticed it when you sit in the commercial aircraft. The engine is on full power and you can hear the engine loud, but the aircraft
mm,
hasn't even started moving that much.
mm,
You see, that is where the differentiation comes of the heavy aircrafts and the big aircrafts, because
mm,
they need a little bit more time to start moving. When you come to land, they need a little bit more speed, because if you cut the speed, the aircraft falls down. The speed is one of the only things keeping it in the air apart from the wings. So
mm,
those are the differentiations that when you go to the class and the different types of aircrafts where you see them, that okay, you know what, this is the aircraft that is, the ones that we fly now are 2,700 or 2,400 kgs. Those
mm,
ones we can push it manually. You see, like
mm,
we can literally push those aircrafts and park them ourselves. But once you take the multi-engine and you
mm,
sit on the multi-engine, you feel like, okay, you know, this is the same aircraft, but it has double the power, but it's the
mm,
same size, 2,500, 2,900 kgs. It hasn't even crossed 3,000 or 3,200 kgs. So you're in a like you're in a similar type of aircraft with that you used to use in a single engine, but
mm,
now they have put two engines for you.
mm,
So then it becomes faster for you. But
mm,
then now you have two engines, but you are way bigger and broader than you actually are, or
mm,
that you actually are used to in those small aircrafts where you can just look to the left, my engine is there, look to the right, my engine is there. You know, so that is the differentiation when you come into the different types of aircrafts and their weight categories.
okay, thank you.
Oh, most welcome, sir. Anybody else? If
If I may add to
and that
that,
is
sorry.
sure. Sorry, please go ahead. Please go ahead.
No, I'm saying if I may add to your answer, there is also a question of maneuverability. The
Yes,
heavier
sir.
the plane, the less maneuverable it will be. A 45-degree bank on a small airplane, it can make you turn, but in a bigger, heavier aircraft, you need a longer arc to turn the big bird. So maneuverability is
Sure.
also another factor in in categorizing these heavier
Types of
airplanes,
aircrafts.
lightweight planes.
Sir. Okay, I hope that was fun, and I hope the answer was okay. All right. So moving forward now, we have we move into the theory part of this theory part. Before we enter into it, it's just we want to look at the cross section of an aeroplane, or the wing of an aeroplane. Sorry, the wing of an aeroplane is the most well designed, I should say, the most well designed technology we have for creating lift. Because we have the engine, we have engines in cars, we have engines in bikes, we have engines, scooters, but none of these fly. So, so I just before going into this principle of Bernoulli's, uh, the way that he, or the way that they deducted this part of how and when a high pressure and a low pressure is created, and how they just stole it and designed the whole wing on that simple principle. We're just going to go through that little bit, and after that, we are, I think, we just go to the simple workings of an aeroplane. Okay, so if this picture that is in front of us, it says that as speed of the fluid increases, the pressure decreases. The a higher pressure accelerates fluid towards lower pressure. Okay, imagine this is how I was taught this principle by my instructor. Imagine you're holding a pipe and you're putting water on your plants. As soon as you press the pipe at the tip, what happens to the water? Anyone? You can stop
More pressure.
when more pressure. Thank you so much. Okay, so you have more pressure. What do you do to have more pressure? You reduce the area of the pipe. You just you just reduce the area of the pipe, and the pressure increases. So I don't know if you can see the relation of, if the area reduces, the pressure will increase because the same amount of water has to come out. Okay, I hope I'm not losing anybody, because this principle is, like I said, this is the way lift is produced in an aeroplane. Okay, so when you have this middle section of the pipe where you have pressed, in the middle, the water is going the fastest, and the pressure is the lowest because the speed is the highest, according to this theorem. So what Bernoulli did was, he took the bottom part of the this red part. Yeah, I don't know if I can show it to you. The Roland, yeah, that part. Yes, just the down part of it. Yeah, I don't know if you can see how the wing is taken out from the bottom of that part. Yes, just there, Roland, that line, the curve on top and the line. Yes, that whole curve and the line beneath it, that is the cross section of the aerofoil. I don't know if you all can see it. Please let me know if you can see how you just take out that small section on the bottom of the diagram and it becomes the wing cross section. Is it visible to you all?
Yes, yes.
Okay, so you've seen how there is less pressure on top and there is more pressure beneath. There's less pressure on top because the air has to flow faster from on top. Yeah. So imagine this is the airplane, it's flying this way. The air comes, there's air that goes on top, there's air that goes below. The wing of the aeroplane is designed in such a way that the air that is flowing on top goes faster than the air that is flowing below.
Okay.
Is it clear now? So when you're going through that air, all the air that is going on top of the wing of the aeroplane has to go faster than the air that is going below the wing, because once they separate from here, they have to meet at the end of the wing as well. Yeah. So that is the way it is actually built. So the bottom, the air that is going on the bottom is always slower. So once you know that the air that is going on the bottom is slower, it has a higher pressure. Now that high pressure that is underneath the wing, with the help of thrust and obviously speed, the pressure keeps increasing and increasing and increasing. And that increase in pressure on the under of the wing is what gives lift to the aircraft. So that is the whole basic principle of how the low pressure under the wing, sorry, the high pressure under the wing, because due to low speed, always that is the balance of it. It has to be low speed, high pressure, high speed, low pressure. So that is the function and the working of the aerofoil or the wing of the aircraft. It is used to maintain and produce lift for the aircraft. So this principle that Bernoulli took out from the high pressure and low pressure is what helped build the cross section of the aeroplane, or the aerofoil of an aeroplane. That is the simplest explanation of Bernoulli's theorem. Okay, I'd wait now because I hope this was clear.
Question.
Sure, sure.
Sorry. Um, I just want to make sure if I understand. So are you saying that this pipe in your illustration, these are the fans or turbine, whatever you call, in the wings of the airplane, and so the air goes through it, and that's what it makes the change?
Not the pipe, the diagram below the pipe.
Okay.
You see, yes, you see the small, the shape, it's shaped like the bottom of the pipe. Just the shape of it is like the bottom of the pipe.
So in the wings of the airplane, what makes the difference? The fans that are in the wings of the airplane, or the system that it has in it? I didn't get it. I understand the principle behind, like the lower speed, the higher pressure, and you said that down is
okay. So this principle is just for the wing, yeah. So now
yes.
you know, just to make it clear, we already know that there are engines in the aircraft, or in the airplane.
Okay.
There are engines, right?
Yes.
So these engines use their power to keep the aircraft going straight, yeah, to keep moving in the air. The engine is going to work on the ground the same way it works in the air.
So are you saying this actually is the engine? It's not in the
No,
wings
this
itself?
is the wing, yeah? But the
Okay.
engine is what is used to make the aircraft move. Okay, so now once the engine makes the aircraft to start moving, the wind that is coming, because the aircraft is moving, the wind that is coming is what creates the low pressure underneath the wing. I'm not sure
Okay.
if,
No,
okay,
I
so
was just wondering what really controlled this thing that to get the wind slow down the airplane and faster on top. So I
yes,
was just
so,
thinking, what is the thing that really makes it happen like this? Is
okay,
it
no,
the
the
wind
engine,
or the engine?
the
Okay.
engine, the engine helps the wind do this.
Okay.
Okay, so the engine is what is making the aircraft move fast or slow. When the engine makes the aircraft move fast, that is when the pressure underneath will become more and the pressure on top will be less. So you see, when the aircraft starts going, it's slow, slow. Once it starts going fast, it slowly gets into the air. That is how the aircraft is built. So as pilots, if you don't touch anything and you add power on the aircraft and it keeps going straight, once it reaches a certain speed, the aircraft itself, because of the speed of the air that is going above and below the wing, it will lift off itself. That is the principle of this man, that if you have this design as a wing and you put an engine in front and you want to go through with this, and this wing is going like that, once it goes fast enough, that because of the principle, the wing itself will take lift and start flying. And now the work of the engine is just to keep that constant amount of air flowing over the wing. If you reduce the amount of air that is flowing over the wing, it will start coming down again. You increase the amount of air, it will go up again, like that. So the engine helps to keep the airflow over the wings to generate that lift to keep the aircraft in the air.
Thank you.
All right. If I may add.
Sure, sure, Mr. Musa.
Sure. So the top image is the original research that Daniel Benoli was doing. This guy was not an aircraft specialist. He was a fluid dynamics physicist, this Daniel Benoli. But he established this really powerful discovery that faster moving air has low air pressure and slow moving air has high air pressure. But he was doing fluid dynamics research. Yes. And he was not alive when they started applying it on aircraft. But this was the principle that actually made it happen. And so what makes it lower pressure or higher pressure is a speed. You see the wing is flat at the bottom and curved at the top. So what the instructor is trying to tell us is that the engine's job is just to move the aircraft forward. And when the aircraft is moving forward, the air is pushing back. When the air hits the wings, it splits. Some of the air will go on top of the wing, some of the air will go underneath the wing. But they have to meet again at the end of the wing. Now, because the surface distance on top of the wing is higher than the surface on below the wing, that means the air that goes on top of the wing will have to travel faster in order to meet up with the air that is underneath the wing.
Below.
And if below the wing, yeah. If it travels faster on top of the wing, guess what? It will have less air pressure. The one that travels slow underneath the wing, guess what? It will have more pressure. Now, Bernoulli's principles say faster moving air has a lower pressure, and slower moving air has higher pressure. But again, it also says that the forces underneath the wing, which is a higher pressure, will then strive to go to the lower pressure to meet up. And that's what creates lift. If you have lower pressure, more pressure underneath it, trying to meet up with a less pressure on top, that creates a lift. And your next question, Daily, was how do they control? So as what he said, if you don't do anything, this will happen anyway, because the higher pressure will still lift up in order to balance with a lower pressure on top. But in aircraft, you have some things also at the end of the wings called flaps. So they control the flaps to create either more pressure underneath or a little bit less pressure underneath. So on takeoff, if it's heavier, with the question that they had earlier, you just put the flaps very low, which creates a lot more pressure underneath to lift the heavy machine to go up. When you want to level, you level the flaps and the air is more or less balanced. So that's simply what lifts the air up. The engine, bring it forward so that it can get the air resistance coming up, split the air, low pressure, high pressure underneath, high pressure tries to balance with the low pressure.
Low pressure on top.
Get the lift, the aircraft flies.
Thank you. Thank you, sir. I hope that was really clarifying.
Yeah, maybe I have two questions to add on to that.
Sir.
I mean, during the time of a windy season, if there is heavy wind, how do you contribute with the engine, and how do you balance it? Do you run the engine differently on sites, or how do you balance it?
We have some aircrafts have, they call this thing feathering. So that is even far, sir. The main principle of this, when the wind changes, that's why you have runway change. You always take off and land into the wind. Into the wind. So if the wind is blowing this direction, you will take off into the wind, because the principle says we need more wind to come over the aircraft. So that is the whole principle of if it's windy or not windy. So if you're landing and the wind is coming from your left, you turn your nose into the wind to land. It doesn't matter where the runway is. You as the pilot will adjust that of, don't think your engines are going to save you. The position of your nose into the wind is what is going to determine how long you can stay in the air. Like that. Yes, sir.
Yeah, thank you for that. And the second one may sound silly, but as a layman, I have to ask, do they have reverse gear in the airplane? How do they go back? Like while parking or something?
Mostly they use a tow truck, or
so it doesn't.
I honestly don't know the name of it. No, sir. They have reverse thrust.
Okay.
But they don't have reversing. So as soon as it lands, few of the aircrafts, or when it's a big aircraft and it's a short runway and you need to stop quickly, they have this thing called reverse thrust, where your thrusters will reverse itself so that it adds to your braking. Yes, sir. Yeah. But actually for reversing, I don't want to say no, but I doubt that they're, because I think there should be, but I've not seen so far that in an aircraft having a reverse gear. It's all either we push or the towing truck pushes it back, sir. Yes, sir.
Okay, thank you.
They use what we call a pushback.
There we go, pushback.
Yes. It's just connected to the front tire. Then that is the one that will be controlled.
The nose wheel.
Yes.
Yep. All right. Okay, so now we found, we already got the principle of how the aircraft stays in the air. We found out that the wings The engine helps the airflow come over the wings. That is what helps create lift. High pressure, low pressure stays in the air. But then we all know this principle and we have all studied this, that for every action, there's an equal and opposite reaction. So if there is something that is keeping the aircraft up, there's something that is pulling it down. If there is something that is pushing the aircraft forward, at the same time, there's something that is equal and opposite to that that is pushing it or holding it from going forward. So this is what we call to keep the aircraft in equilibrium. I hope I said that properly and didn't mess it up. But in balance, that if you have a upgoing force, you have a downgoing force, you have a forward going force, you have a backward going force. So this is, okay, I'm trying to go to the next slide. Okay, so that is, oh my, okay. All right, so these are the four forces that are on an aeroplane at all time. The upward one is called lift. The one to balance and counter lift is weight. So we have lift, we have weight opposite to lift, and then we have thrust, that is the engine power to keep it going front. And then we have drag, which drag is now the opposing, okay, the opposing force to thrust, something that holds it back. So now, as the diagram shows, you can already see that if if this is equal, if this is equal, it is not going anywhere. True? Like if this is actually equal, if lift is equal to weight, and if thrust is equal to drag, that means it is in homeostasis, it's not moving, right? So something has to be done so that it can move, but at the same time, stay equal, right? So the way it is made is the lift and thrust, that ratio has to always be more than the weight and drag. The going front and going up has to always be more than the backwards force and the weight. So to counter this, what the manufacturers have done is the center of gravity is in front, sorry, it's behind the center of, oh, sorry, in front of the center of pressure, right? So the center of gravity pulls the aircraft down, but where the pressure of the wings or the lift is in front. So it always, whatever you do to the aircraft, the physical property of the aircraft, because these forces are all acting on the aeroplane, the minute you add thrust, because the center of pressure is in front and the center of gravity is behind, the aircraft tends to move on top. Now this is when the aircraft is on the air, not on the ground anymore. Okay? So once it's in the air, the minute you add any amount of power to an aircraft, the nose of the aircraft will automatically go up. That is to keep it in balance, always in balance. That is how we keep the aircraft in balance. So the center, that is the dynamics now of how the ratio works. But to know the four forces that are always acting on the aircraft, which is the requirement now, is you have four forces always. The thrust is going to always help the aircraft achieve lift. So if you add power, as we have said, more airflow over the wings. Once you have more airflow because of the high pressure, low pressure, and the meeting of the wind at the end of the wings, it creates lift. So thrust always helps create lift. Weight always counters lift and thrust with drag. So now when you have extra weight, like the heavy aircrafts, you already know that you're going to have extra drag because of the weight of the aircraft or whatever may be. If you have a heavy aircraft and it's heavy, the weight increases, you know that you have more drag. So now to counter that, what they do is add more thrust. So the heavier the aircraft, the more thrust that it needs to produce to keep the aircraft in balance when it is in the air. So that is the basic four forces that always act on the airplane. It doesn't matter whether it's on the ground, whether it's on the air, whether it's turning, whether it's climbing, whether it's descending, whether it's stalling or spinning. These are always the four forces that act on the airplane at all times. Okay. Any questions about the four forces? Or because this is like the very basic of just to know that no matter the aircraft is on the ground or in the air, it will always have these four forces acting on it at all times. Okay, we'll move to the three principal axes of an aircraft. The three principal axes of the aircraft. So we have the lateral axis, we have the longitudinal axis, and we have the vertical axis. Okay, so let's say, let me get the scale. This is the longitudinal axis. Yeah, a pen is better, guys. So this is the longitudinal axis, right? It is straight. I don't know if you all can see this. It's a pen. It is straight. Yeah. I don't know if you all can hold a pen with me and we go through this. This is the simplest way that I learned it. So I don't know. Okay. So this pen is straight to you. Yeah. It's straight. It's straight to you. So this is the longitudinal axis. What can we do with the longitudinal axis? Like, how does it move? If these two are like, okay, I'm just going to turn it to the side for some time. Okay, so this is the longitudinal axis. These two are attached. What can it do? How can you move this if these 2 points are attached to each other? This is the longitudinal axis, guys. So how can we move this? What is the only possible way to move this pen? I know I cannot move it up and down. Spin it around. Thank you. Spin it around. So how does it move around the longitudinal axis? Left to right, left to right. That is called rolling. Rolling. So you're holding your longitudinal axis straight to you. It can only move left or right. Left or right. That is rolling about the longitudinal axis. So the longitudinal axis, it looks straight. Yes, it looks straight, but you can only go from left to right because these 2 points are stuck to each other. Okay, so we roll about the longitudinal axis. So we go now, we have now the longitudinal. Now we go to the lateral, that is the wings. Okay, so this is the longitudinal, this is the lateral, yeah? This is the lateral. If we hold these 2 points, what can it do? Same thing, right? Up and down, up and down. We cannot move to the side, nothing. It's just up or down. Can you see the scale? So this is your lateral axis. This is your longitudinal axis. Okay? So with your longitudinal axis, you turn left or you turn right. With your lateral axis, you go up or you go down. Okay, so that is your pitching. You pitch up or you pitch down. Your lateral axis. The lateral axis is where your wings are. So if you hold these two together, you can only go up, you can only go down. That is the basic simple principle of how you hold your lateral axis. Okay, if you do it with the pen, so because for me, I do it always with the pen. Longitudinal axis, if you hold these two parts, it can only go left, right. That means you're rolling. If you hold it this way, it can only move down or up. That means you're pitching the nose down or you're pitching the nose up. So those are your longitudinal and your lateral. Now we have your vertical axis, or also known as your normal axis, which is straight through the aircraft. So it is straight down like this. If I hold these 2 points, the same thing, it can only spin about these axes. So it will again go to the left or to the right. Okay, so this is your normal or your vertical axis. You can yaw. It is called yawing to the left or to the right. Okay, so now you have your longitudinal axis where you roll. You roll about your longitudinal axis. Then you have your lateral axis where you pitch up or you pitch down. And then thirdly, you have your normal or your vertical axis where you yaw left or you yaw right. So it has 3 principal axes: longitudinal, lateral, and vertical. These 3 axes help the aircraft to maneuver itself. So within these 3 axes is where you will turn, you will climb, or you will descend. These are the 3 axes of an airplane. To keep this, basically, these 3 axes are just so that you can actually maintain and keep your, or you know, the function of your control surfaces, which is what we'll get into, I think, tomorrow. We have a lockdown here, but we'll see what we can do. But these 3 axes are what control your control surfaces. Okay, so these 3 axes control your control surfaces. So now when I say these control surfaces, just remember or just keep in mind that we have, as pilots, we also have something inside the cockpit to control the aircraft, do these things that are written. We have a control to roll the aircraft, we have a control to pitch the aircraft, and we have a control to yaw the aircraft. Yawing is just when you're on the ground, left to right, that is yawing. Okay, so those are the 3 axes of the aeroplane. Next, we will, okay, any question about the axes of how axes or the 4 forces that act on the aeroplane? Okay, okay, so we are, okay, so today we just start doing this and we will go through The types of aircraft, the types of engines, we can finish that up tomorrow. We'll do the types of engines. So tomorrow we will do the special types of wing designs. We'll do them tomorrow. And then after we finish the engines, we finish the wing design, we'll go through the instruments of the aircraft. After we go through the instruments, we will go through the different parts of the aircraft. Once we finish the parts of the aircraft, we will start our helicopter. We'll just go through a little bit of the rotary type, and we will see, like how we said in the beginning, just the lighter than air aircrafts, just to know that if it doesn't have an engine, or if it has a small engine, then it is called lighter than air, where most of you must have seen these gas balloons or these helium blips that they have around. Those are your, lighter than air, but we'll go through them in detail tomorrow as well. Thank you. Thank you all for joining today. I think we finished quite a bit. I hope it's not too much. We'll just go through the